Okay, so biconditional uses this symbol, and that's like an if and only if. So let's make up our truth table for this. So if I have P and Q, so true, true, false, false, true, false, true, false, and P if and only if Q. So if true, then true, and does it go backwards? Yes. If true, then false. If false, then true. Nope, that doesn't work. If false, then true. Nope, those don't match either. How about this one? If false, then false, and if false, then false. Yes, that's right. That's correct. Okay, so in your notes, you have something written here. I've moved it later on, so I'll talk about it. So just save it for later. Okay, a tautology. A tautology is when a statement is always true. So this is a statement. So I'm going to make the column for P. So that's true and false. And then I'll make the column for not P. So that's false and true. And so now let's do P or not P. So that means if one of them is true, I'm true. So is one of them true? Yes. Is one of them true? Yes. So that's why it's called a tautology, because this statement, right, this here is this column here, this is always true. Contradiction is when it's always false. So let's do the same thing again. So P is true, false. Not P is false, true. So P and not P. Okay. So this is when they have to be the same. True and false? Nope. False and true? Nope. So it's always false. All right, so we're talking about sufficient conditions. So R is a sufficient condition for S, means the same thing, if R, then S. A necessary condition, R is a necessary condition for S, means if not R, then not S. So we're going to give this a special name later on, but let's start to get used to it. If not R, then not S. And this is also a way of saying if S, then R. So notice they're switched in this one, right, with the nots. Okay, so here we go. Let's just play with this one. If John is eligible to vote, then he is 18 years old, at least 18 years old. So this is the if, right? If this, so this is a sufficient condition. If he's eligible to vote, that must mean that ensures that he is 18 years old. So if he is eligible to vote, that's sufficient to ensure the truth of this beginning statement. Okay, so let's look at this one here. So here I have a statement right here, and I want you to rewrite it with the if A, then B. So John's birth on U.S. soil is a sufficient condition for him to be a U.S. citizen. Oops, him. John's not usually a girl. Okay. So I'm going to say if John, born on U.S. soil, then he is a U.S. citizen. Okay, so I kind of did things out of order, so scratch this out and just change this to write. Write the following statement in two ways. Okay, so here's where I'm using the phrase necessary condition, and so there's two ways. There's this way and this way. Okay, so let's rewrite this in two ways. So the first way, so George attaining age 35 is a necessary condition for his being U.S. president. Okay, so let's do this. This would do this one first. So I'm going to say if not R. So if George is not 35 years old, then he cannot be president. So that's using this first one. Okay, so let's try the second one. So we're going to say if S, then R. So if George is president, is president, then he is at least 35 years old.